my 40 years consulting across ASEAN manufacturing, one mistake I see again and again. Plants spend millions on mitigation hardware, but have no monitoring system to tell them whether it's actually working. Or worse, they have a voltage dip event. Operations blame the grid authority blames the plant, and nobody has the data to prove either side right. Power quality monitoring is the foundation of everything. Let's get into how to do it right. There are 3 strategic reasons every power-sensitive facility needs a permanent PQ monitoring system. First, system resilience. Continuous data lets you identify which equipment is operating at the margins of its voltage tolerance before it trips during a dip event. Second, fault direction analysis. After a dip event, your PQ monitor tells you whether the fault came from upstream, meaning the grid, or downstream, meaning within your own plant. This is your evidence in any regulatory or insurance dispute. Here's the diagnostic. If the current magnitude increased significantly during the dip, the fault originated downstream from your own equipment. If current stayed flat or dropped, the grid is responsible. Third, energy management. The same monitoring infrastructure gives you harmonics data, power factor trending, and energy consumption patterns to drive ESG reporting and cost reduction. When selecting a PQ monitor, the most important criterion is compliance with IEC 16100-430. This standard defines 2 tiers, Class A for high precision, legally binding measurements, and Class S for general purpose monitoring. For semiconductor fabs, EPC contractors, and any facility where voltage dip data might be used in a regulatory dispute, you must use Class A. The key technical differentiator. Class A monitors use ERMS half, that is, RMS voltage calculated at every zero crossing of the waveform, every half cycle. This gives you 0.1% measurement accuracy and captures sub-cycle events that Class S monitors can miss entirely. For memory storage, permanent monitors need at least 1 month of trending data, plus a minimum of 20 disturbance waveform captures. Portable investigative units need significantly more. One final selection criterion that's often overlooked: software usability. You need zoom, pan, marker measurement, and easy export to PDF or text for your engineering reports and EMA submissions. The bottom line for Chapter 2: without a Class A IEC 61430 compliant monitor at your HV intake, you are flying blind. You cannot defend yourself against wrongful regulatory action. You cannot prove your mitigation hardware is working, and cannot build the historical dip data you need to make smart investment decisions in the next chapters. Speaking of smart investments, in Chapter 3, we'll introduce the full 5-tier protection hierarchy and show you how to match your solution to your risk appetite. Subscribe to the channel, share this with your M&E consultant or facilities team, and connect with me on LinkedIn for more ASEAN industrial insights. See you in the next chapter.